Hello friends, welcome back. Today we are going to see Saint Venant's principle from theory of elasticity. Saint Venant's principle is the term, a famous term, it's often used in structural mechanics textbooks and in the subject of theory of elasticity. Basically, it explains uh, the effect of redistribution of forces on the stresses developed in the material or any object. This principle is proposed by famous French scientist Barry Saint-Venant in the year of 1855. Basically, this is more or like a observation than a mathematical statement or formula. The statement says that if the forces acting on a small portion of the surface of an elastic body are replaced by another statically equivalent system of forces acting on the same portion of the surface. This redistribution of loading produces substantial changes in the stresses locally, but has a negligible effect on the stresses at distances which are large in comparison with the linear dimensions of the surface on which the forces are. Very simple. Consider that you are applying a force on an elastic body and there will be a stress developed inside. When you remove the force and replace the force with another set of forces which are equivalent in the magnitude. Now this redistribution of forces create substantial changes in the stresses locally, that is at the vicinity of the point where the forces are applied. But the effect will be negligible in the longer or farthest distance from the application of the forces. That's what it says. So let us see with some illustrations. Here you see a stress contour from a stress analysis software where the different colors explains the different intensity of stresses developed in the body due to the applied force. So as you see these three examples, there are three different types of forces are applied. The first one is uniformly distributed load, the second one is a parabolically distributed load, and the third one is a concentrated load or a point load. As you see the redistribution of forces, and the thing should be noted is uh, the magnitude of these three different forces must be same. So whatever it is, whether it is a uniformly distributed load or a parabolic load or a concentrated load, the magnitude remains the same. Say for example, it must be 150 megapascal or 200 megapascal. So all the forces are 250 megapascals or 200 megapascals. Whatever it is, it should be same. So now if you see with the help of the stress contour, the color, the area around the hole in the three cases shows that there is no change in stress since the map, the contour looks similar in all the three cases. Whereas if you see at the point very close to the application of forces, at this point, for example, help of laser pointer, if you see here, you see there is no change in the stress level, which means the stresses are uniformly distributed. So there is no difference. If you see, so wherever you have a higher intensity, you see a higher stress developed over here. And for the concentrated load, so at the point of load, you have a very high level of stress and it gradually decreases as you move along. But at this distance, you don't have any difference. That's what Saint Venant's principle says. And we'll see with another example with a stress flow contour. Similarly, same type of forces, and these lines shows the stress concentration around the hole, whereas there is no difference in these three cases. So there is no effect due to the redistribution of forces. As you come down, the redistribution of forces here doesn't produce any change in the three cases, whereas you see here, so due to the redistribution, there is a change in the stress concentration at the points very close to the area or surface where the force is being applied. So this is what Saint Venant explains. The redistribution of forces have negligible effect in the farthest distance, whereas they have a considerable points very close to the surface at which the forces are being applied. Thank you.